before the compiler, so you can actually put anything into a macro expansion. Macros are evil.
I've seen examples where demonstrating what the preprocessor does, you define begin block, open curly bracket, end block, close curly bracket.
But that's expanding to a curly brace.
Yep.
You know, whether it will take curly brace as a parameter, that's a different question. You see what I mean?
It won't.
I'm sure it will, because the preprocessor gets control first, and the preprocessor has no understanding of the meaning of the curly brace at all.
Yeah, but I'm sure that once that macro expands, a curly brace there where the less than symbol is that what you meant?
Oh, no, I'm just talking about
Just
in general,
oh,
you know,
sure,
if you are to write your own macro, and can you know, pass a curly brace, you know, to a macro, and the answer is yes. You know, just about anything can be passed to a macro. So that's why, you know, that's why in C99 they deprecated the use of macros, but they're useful. And I do the same thing.
Passing of operators to functions.
I know. C++, man.
C++. Yes. But no one is writing a C++. No one is writing an operating system in C++ either.
Well, why don't you rewrite DRT, KT, KT, whatever it is?
DRRTK, DKRTK. Yes.
You can't even remember the macronym.
Do they do embedded programming in C++?
Not a whole lot.
Is there a reason for that?
Because of the extra cost of C++.
As in
Greater
memory
licensing
usage,
fees.
or in
No, it's just, you know, most programmers, you know, cannot refrain themselves from using, you know, bigger data structures and stuff like that.
But if you don't use the larger data structures, not really losing any size.
That is correct. Yep. If you use it for organization purposes, it's not bad. But the moment you throw in any type of virtual member functions,
Yeah,
then it
it's a
starts
virtual
to
table to deal with.
Yeah, then you have indirect calls and all kinds of stuff like that. And you know, with a with a Pentium processor, it's not a big deal. But if you're dealing with an 8-bit microprocessor with only running at 16 megahertz, division is evil in those particular architectures, because division is all done in software. Yep.
So why don't you rewrite the Dr. Tac real-time kernel in C++ and have just a polymorphic class for all your threads and simplify everything?
No. That's a job for Mr. Fox, not for me.
Come on, you gotta come into the 22nd century here.
I'm still teaching assembly language programming using the syntax that was, you know, invented from day one.
And that's why you're better than us.
Does your assembly class use NASM?
No, we use GAS. We use the GNU assembler. So if you're used to the other one, you know, it will be kind of confusing at first because the order of the operands is exactly the opposite.
AT&T syntax? AT&T syntax?
Yep, AT&T notation. Yep. Okay, so this is a big change. You know, this is actually the big change of the entire program. You know, if I have to name one place where a lot of problems can happen, it would be this particular revision. Because it is in this particular revision that I changed the code so that, okay, let me show you the first change, and you know, from that one I think you can see why I said, you know, this is a big, huge change. If you look at the way I call select, okay, this is the select call. You can see that the select call is no longer selecting only on read file descriptors, it's also selecting now on write file descriptors. In other words, I have a logic now to basically say, okay, which socket should I still be reading from? I would not be reading from one that I have just received a byte, but I have not done echoing or broadcasting that byte to everybody else. So the read FDS is no longer, you know, starting with everybody, because it is everybody except for the sockets that I have just read a byte from, but did not have a chance to broadcast to everybody yet. Is that making any sense? Yes? No?
Kind of one byte at a time.
I'm doing one byte at a time, but I'm also doing it, you know, for each client. Okay? And then the write FDS is based on how many clients I have already successfully written a byte to. So from that I will do a bitwise OR to say, okay, in other words, if the server has to echo the two different characters from two different incoming sockets to the same client, then the two data structures for those two clients will both specify that they want to write to this client, and this guy also want to write to that client. Okay. Now the question is, what if there is room to write to that particular client? Because I can only write 1 byte at a time. I cannot write 2 bytes at a time. So the answer to that has to do with this part here. Okay. Right here, if FD is set client bracket I dot socket FD, write FDS. In other words, I'm ready to be written to. The client is ready to be written to. Who wants to write to me? So now I go through all the client structures and figure out who has a pending operation to write to that particular client. And when that client is written to, then I use a FDCLR to change the BC client member, which is broadcast clients, to basically so that clients I can now remember I do not need to write to this particular client for broadcast anymore. So this way I clear one client at a time when I can write to a specific client. But this does not clear another client who is also waiting to write to this particular channel, which turns out to have room for one more character for this round. In other words, this way I can keep track of 3 concurrent broadcast logic just by scanning through the whole logic every single time to emulate the whole process of broadcasting. So this is the biggest change, and you can see that in this change, I still have not integrated fork or processes into the whole program. This is still running as individual processes. I still have to /socket4 to start the server, /socket4 socket. I have to do exactly the same thing as in socket 3 to start up each and every single client, except they're all using pipes now, and the logic of the server has now changed. Is that making any sense so far? Okay. I also integrate the logic to check whether I failed to read from a particular client. Okay, so if you look at this logic here, right here, okay, so this is the conditional statement, saying that if this client is in the read FDS after the select call, which means it has room, it has 1 more byte available for me to read, I will actually go ahead and reset the timer again. But on the other hand, if I cannot read from this socket FD, but it is supposed to be readable, okay, because try read FDS remembers from which file descriptor I was trying to read, and then the other one, which is read FDS, tells me which ones are ready to be read. So if I look at the difference between those two, I know which ones have timed out. So this is a timeout detection. So when I have a timeout detected, what I will do is I will subtract the delta, which is the actual amount of time that has elapsed from this select call, from the amount of time that is available left for that particular client. So this way, I basically decrement the amount of time left for all the clients that I want to read from, but they did not